It's such a wonderful night, isn't it? With the stars shining brightly above, the moon just peeking behind the mountains over to the east. The Milky Way galaxy spread out above our heads like a painted watercolour. And the whole expansive night sky all to ourselves. When we're lying here on this loch-side beach, staring up at the sky, with the water lapping away and soothing us, combined with a little warm cup of tea. There's nothing quite like it, is there? But we won't get cold either because we've got our campfire. We'll keep it nice and stoked, don't you worry. We've got a wee while to go yet on our journey through the solar system. So how about we continue where we left off? Now just look again down in the sand. You can see where you drew the big circle for the sun. And then not too far from there, only a couple of centimetres, you made a little dot for Mercury. And then another 3 centimetres beyond there, you made a slightly bigger dot for Venus. Then another 3 centimetres beyond Venus, you made a little dot about the same size as Venus for us here on Earth. Now those wee dots are all very equally spaced out, because that's the arrangement on the innermost planets in our solar system. We then explored our own moon, as you can see tonight, right in front of us. So now let's journey a little further out into space. So why don't you measure about 5 centimetres from our Earth in the sand and make a little dot a bit smaller than our Earth. This dot is Mars, and it's 142 million miles from the Sun, or about 50 million miles from our Earth. With its red hue and proximity to Earth, Mars has fascinated man across the centuries. It is the 4th planet in our solar system, and the last of the rocky planets orbiting close to the Sun. The Babylonians associated the planet with war and bloodshed. So did other civilizations. The Romans named Mars for their god of war. The astronomer Giovanni Schiaparelli observed strange markings on the planet in the year 1877. He called them canali, which means channels in Italian, but was translated incorrectly as canals. This sparked the Victorian misconception that Mars was populated by an alien race of innovative canal builders. The focus on current exploration has been water. Water is so important because it offers the tantalizing possibility of life as we currently understand it. In 2004, the Mars exploration rovers Spirit and Opportunity found proof of past liquid water in various surface features. The bedrock of Gusev crater indicates an ancient body of salt water. Evidence of a body of water larger than the Baltic Sea exists in the Terra Meridiani region. Every single rock has shown signs of alteration by liquid water, said lead investigator Dr. Stephen Squires. Three-dimensional images released from the Mars Express spacecraft in early 2005 show evidence of past gigantic waterfalls, huge glaciers, and grand outflow channels. Near the equator, along the Elysium Plains, a photograph taken shows what appears to be a 5 million-year-old frozen sea of water that has been protected from vaporizing by a layer of volcanic ash. Comparable in size and depth to the North Sea, the area features large, irregular plates, similar in pattern to the pack ice at Earth's poles. Following the water trail away from the sea leads to a series of fissures known as a Cerberus fosse. These fractures in the surface were the source of both lava and water floods millions of years ago. In fact, lava plains from the floods are located in eastern Elysium. The find is particularly captivating because, on Earth, microorganisms have been found around deep-sea thermal vents. If the Elysium seawater was warmed by past geothermal energy, perhaps it provided the environment for life to develop in a similar form on Mars. The recent detection of small amounts of methane in the Martian atmosphere is further intriguing evidence for living microorganisms on the planet. Methane is a common byproduct of life on Earth, but it can also be produced by non-biological processes. Volcanoes could be one source, but there is no proof of active volcanism on Mars today. Still, all other possible causes must be ruled out before concluding that methane is a biotracer of present-day life on Mars. The atmosphere on Mars is thin, composed mainly of carbon dioxide gas. There are clouds, mist, and fog, but the atmosphere lacks the insulation to prevent wide temperature swings, as much as 180 degrees Fahrenheit or 100 degrees Celsius from day to night. Because of this tenuous atmosphere, water on Mars behaves like carbon dioxide on Earth. Frozen water doesn't melt. It goes directly from ice to vapor without any intervening liquid state. This process, known as sublimation, poses a dilemma for scientists in explaining what appears to be considerable erosion on the surface. If water flowed, it must have been at a time when the atmosphere was much denser. The weather report for Mars is cold. Surface temperatures average minus 65 Fahrenheit or minus 53 Celsius. And even during the summer, rarely rise above the freezing point of water, 0 degrees. Variations in temperature across the surface produce very strong winds, often stirring massive summer dust storms that engulf the planet. Summers are warmer and shorter in the southern hemisphere than in the north, and the seasons are influenced by the polar ice caps. The main reservoir of water on the planet is concentrated in ice at these north and south poles. Although enormous quantities of water ice may exist underground at low latitudes, the Martian hemispheres are a mismatched pair. The southern terrain is more ancient and heavily cratered, with obvious valley networks possibly formed by past rivers. Along the equator is Valles Marineris, grander than the Grand Canyon. It is a system of deep canyons that spans an extraordinary 2,500 miles. The younger northern plains show indications of former lake beds, and volcanoes dot the landscape. The north's most imposing feature, Olympus Mons, is the largest volcano in our solar system, 100 times larger than even Earth's biggest volcano. Mars's changing seasons, ice caps, clouds, volcanoes and canyons make for similarities with Earth. But that is where the similarity ends. Mars is rocky, cold and barren. It has 2 moons, Phobos, meaning fear, and Deimos, meaning panic. the entire Martian planet is about the size of Earth's iron core. Mars's red colour is derived from the presence of olivine and iron oxide on its surface. It is as if the whole planet is coated in rust. Now let's leave planet Mars behind and venture even further out into the depths of our solar system. But the next stop isn't the next planet. Why don't you measure about 15 centimeters in the sand from Mars, and with that small twig over there, dot lots of teeny little holes in the sand in one big line, kind of scattered around loosely. This is the Asteroid Belt, and this lies approximately 150 million more miles beyond Mars, 300 million miles from the Sun. Now, most asteroids orbit the Sun in this gap between Mars and Jupiter, our next planet, and this is known as the Asteroid Belt. Asteroid orbits are usually stable for millions of years. However, because asteroids are so small, and there are so many of them, their orbits are not confined to a single elliptical plane like those of planets. Asteroid orbits span a large range of inclinations due to the long-term effects of the gravitational pull of Jupiter, Mars, or other nearby asteroids. Asteroids are basically space rubble. Dark rocky fragments created during the formation of the solar system almost 5 billion years ago. This orbiting debris is the leftover material that didn't quite come together to make a planet or a moon. Asteroids come in irregular shapes and sizes. Some are larger than the length of Italy, whilst others are less than a few city blocks in diameter. So these asteroids tumbling through space, have asteroids ever hit Earth? It is believed that a huge asteroid or comet slammed into what is now the Yucatan Peninsula 65 million years ago. Asteroid hits are rare, but meteoroid hits occur almost continually, adding tons of material to our planet every day. Meteoroids are often the offspring of these asteroids or comets. Okay, now back down onto the sand we go for our next visit to the next planet. And this planet is, of course, Jupiter. So down in the sand, measure another approximate 20 centimeters further out than this asteroid belt. This deserves a big circle because Jupiter is the biggest planet in our solar system. Named after the Roman god of all gods, Jupiter is the largest planet in the solar system. Second in brightness after Venus, as viewed from Earth, Jupiter could be filled with over 1,000 Earths. Yet it measures only 1/10 of the Sun's diameter. The planet is like a bustling metropolis with many satellites, a colourful ring system, turbulent storms, and streaks of lightning. Like the hub of a great city, Jupiter is big, bright, and commanding. In the year 1610, Galileo discovered Jupiter's 4 largest moons: Io, Europa, Ganymede, and Callisto, all of which are now called the Galilean satellites. Today, though, we know that Jupiter has at least 63 satellites, the most of any planet in our solar system. Scientists speculate that many of the outer moons may be asteroids caught by the planet's intense gravity. Jupiter is one of the 4 gas giants, along with Saturn, Neptune, and Uranus. In composition, Jupiter is very similar to a star. In fact, the gas giant sends out into space more than 1.5 times the heat it receives from the sun. Yet, even with all the right stuff, Jupiter falls short of the weight requirement for a star to ignite. The planet needs about 80 times more mass for fusion to commence in its core. Even though Jupiter has no solid surface, its designation as a gas giant is strangely misleading. The majority of the planet is made from hydrogen under such supersized pressure that it has turned liquid and metallic. Jupiter is divided into 4 main layers: a thin outer envelope of gaseous hydrogen, a deep sea of liquid hydrogen, an even deeper sea of liquid hydrogen acting like molten metal, and a hot core of ice and rock. Jupiter has a strong magnetic field generated by electrical currents deep in the planet's liquid metallic hydrogen layer. Within the magnetic field, there is an abundance of charged particles. These particles create dangerous amounts of radiation, which bombards Jupiter's rings and moons. The planet's strong magnetic field interacts with the solar wind to create a magnetic tail that extends as far as Saturn's orbit. Now, when most people think of Jupiter, they think of its most defining feature, and that most notable feature may be its great red spot, a huge storm system more than 12,500 miles across, or about twice the width of Earth. It is, in fact, the largest storm in our solar system, and it has been there in Jupiter's southern hemisphere for at least 350 years. That is since English naturalist Robert Hooke first reported it. But it is now only half as big as it was a century ago. The Great Red Spot is a vortex of high and cool clouds, driven by strong winds of up to 250 miles an hour. Scrunched in between two jet streams in the upper atmosphere, this mass of clouds twirls upwards and rotates counterclockwise every 6 days. It is anticyclonic, that is, a high-pressure system unlike the low-pressure cyclonic hurricanes on Earth. Storms like this one last so long on the gas giant because there are no solid surfaces below to break them up. Along with smaller cloud systems that act like thunderstorms, the Great Red Spot is located in Jupiter's kaleidoscopic cloud lanes. When one sees an image of this big spot, the lighter bands are rising gases called zones, whilst the darker bands are descending gases called belts. Perpetual strong winds, steady alternating jet streams, and the fast rotation of the planet all contribute to these atmospheric stripes. And the day on Jupiter, by the way, is just under 10 hours. Perhaps lesser known than the neighbouring Saturn's rings. Did you know that Jupiter also has rings? Jupiter's ring system was first discovered in 1979 by NASA's Voyager 1 spacecraft. We now know that the planet's ring is made up of 3 major sections. The main ring, approximately 4,000 miles wide, is encircled by the orbits of 2 small moons. These moons are called Adrastea and Metis. Its inner border merges into the faint and thickest ring, called the halo. This donut shape extends halfway from the main ring to Jupiter's cloud tops and may be caused by the electrical charging of particles that spiral inward. Neighbouring the main ring on the outside is a pair of faint gossamer rings. One of the pair is contained by the orbit of the moon Amalthea, and the other by the moon Thebe. The gossamers are thicker than the main ring due to the inclined path of the two moons as they circle Jupiter. The Jovian ring system is highly tenacious and uniform, composed of tiny dust particles, only a few microns in diameter. Astronomers speculate that the rings may be formed by dust kicked up as an interplanetary meteoroid smashed into the planet's inner moons. It is now that time again where we must take to the sand by the loch-side and draw another relatively large circle. Not as big as the Sun, obviously, but slightly smaller than Jupiter's one. Because we are travelling another 400 million miles out to space, or 40 centimetres from Jupiter, to visit the most stunning and iconic shape that is the planet of Saturn. When we have actually seen that great arc swung over the equator of the planet without any visible connection, we cannot bring our minds to rest, wrote a Saturn-struck James Clerk Maxwell in the 1850s. The ringed planet continues to fascinate as the most exotic in our solar system. It is also the second largest, 75,000 miles in diameter, and the most distant planet easily visible to the naked eye. I myself can recommend to everyone, should you have access to a telescope, to track down Saturn and see it for your very self. Because to see the rings, iridescent as ever, with your own eyes is a truly remarkable experience. The hundreds of thin, wide rings can be seen with a small telescope. They change in appearance relative to the tilt and the position of Earth and Saturn, sometimes opening wide, other times narrowing to almost nothing, edge on. They consist of billions of particles of ice and rock, caught in the planet's gravity as in a fisherman's net, then sent spinning in a majestic hula hoop motion. Although the other gas giants also have orbiting rings, Saturn's are the biggest and brightest. With the exception of the Cassini division, an expanse of 2,900 miles. They are relatively close to one another, reinforcing the halo effect as seen from Earth. Named for the father of the god Jupiter, Saturn has at least 33 moons, most discovered since the year 1980. The largest, Titan, is bigger than Mercury. Saturn spins on its axis in just 10 hours and 15 minutes. But due to its distance from the Sun, nearly 1 billion miles if you've been counting on the sand, Saturn takes 30 times as long as Earth to complete its orbit. One of the 4 gas giants, Saturn is composed mainly of hydrogen and helium gases, with a hot, rocky core and a south pole that, amazingly, is the warmest place on the planet. Atmospheric pressure is sufficient to cause Saturn's gases to condense into a sea of liquid hydrogen about 250 miles below the cloud tops. The planet's density is the lowest in the solar system. Its specific gravity less than that of water. If there were an ocean large enough to contain it, Saturn would float. The atmosphere is composed of 3 layers of clouds: white, orange, and blue, and capped with a thick layer of haze. Storms more forceful than Jupiter's occasionally climb through the haze and appear as white clouds of ammonia ice. Winds in the upper atmosphere reach speeds as high as 1,100 miles an hour as they whirl around the equator. The winds, in combination with the heat rising from the planet's interior, account for the yellow and gold bands visible in Saturn's atmosphere. The synergy of high-speed rotation and the planet's gaseous makeup produces its characteristic flat poles and a bulging equator, the plumpest planet in our solar system, so to speak. In the year 2004, after 2 billion miles and a 7-year journey, the Cassini Huygens spacecraft entered Saturn's orbit to give the planet some close-up photographs. Saturn's ringscape is like a mini solar system where the planet, the moons, and ring particles are balanced in a collaborative display. The inner satellites play a key role as they choreograph particles to clear gaps, create waves, and form little ringlets. Even though there are a multitude of ringlets, the ring plane is divided into 7 main rings, designated by letters. They go in order of D, C, B, A, F, G, and E, in order from the planet. The closer rings orbit Saturn at faster speeds. Density waves within the rings are the result of nearby passing moons. The revolving moons disturb the orbits of particles, and density waves are formed as particles move closer together. The Cassini division between the B and A rings is the largest apparent interruption of Saturn's grooves. The inner boundary is formed by particles located on the outer edge of the B ring. They orbit Saturn twice for every time the moon Mimas goes around the planet once. This process is called orbital resonance. One of the smaller gaps, the Encke division, is located in the outer portion of the A ring and is formed by the orbital path of the tiny moon Pan. Wee Pan acts like a rotating broom, sweeping away debris as it moves through the gap, causing rope-like braids and wakes along Encke's edges. Satellites Prometheus and Pandora perform a different role by shepherding the F ring into a narrow strand. Prometheus is on the inside of the ring, Pandora on the outside. The gravitational forces of these moons corral any material trying to escape. Little brooms indeed. And just like that, it's back out to space we go. This time even further away. Up until now you might have assumed the distances we were working with are enormous. But this is where perspective really comes into it. Our solar system is not big on the scale of our galaxies and of our universe. But already the next planet is another 900 million miles, or 90 centimeters on our sandy beach, from the previous planet of Saturn. The distances seem to get larger and larger as we venture further out into our solar system. The next planet is, of course, Uranus. On the Voyager project, We used to call Uranus a featureless blue tennis ball, said planetary scientist Dr. Ellis D. Minor. In fact, it is anything but. Uranus is the third largest planet in the solar system and seventh from the Sun. It was identified as a comet by British astronomer William Herschel in 1781. Others, including his own son, were the first to recognize that it was, in fact, a new planet. The rings of Uranus, however, were not discovered for another 2 centuries. Named after the Greek god of the heavens, Uranus has 11 rings, some of the brightest clouds at the far edge of the solar system, and 27 known moons. Most moons were named for Shakespearean characters, including Portia, Cordelia, Oberon, and Puck. Miranda, the heroine of The Tempest, features steep cliffs and winding valleys that scientists think may be evident of the partial melting of the moon's interior. Uranus is another gas giant with no solid surface. 80% of its mass consists of a liquid core made up mainly of icy materials. Those are water, methane, and ammonia. Hydrogen, helium, and a small quantity of methane make up its atmosphere. Methane gas above the cloud layers of its upper atmosphere give the planet a distinctive blue-green colour. In the year 2004, observations conducted at the W.M. Keck Observatory in Hawaii identified at least 31 cloud features that changed quite dramatically between viewings. These cloud features are massive storms that could encompass a nation the size of the United States. The clouds, at varying altitudes, are probably made of methane crystals that condense as gas bubbles during their rise from deep inside the atmosphere. Perhaps most interesting is the unique polar orientation of this planet. Uranus orbits the Sun with its axis nearly horizontal to the elliptic plane, like a top spinning on its side. A collision with a planet-sized body early in its life probably explains its tipped rotation, which results in the two poles of this very cold planet receiving the greatest exposure to the Sun in the course of a long orbit of 84 years. It's now time for another nearly 1,000 million mile journey further out to space, to the planet of Neptune. So down on the sandy beach just now, we're another 90 whole centimeters from the previous planet, Uranus. That makes a total so far of nearly 3 meters from the original place of the Sun. Named after the Roman god of the sea, Neptune is the most distant gas giant in our solar system, and the 8th planet from the Sun, a vast 2.8 billion miles away. However, because of Pluto's elliptical orbit, Neptune is actually the farthest planet from the Sun for a 20-year period every 248 Earth years. Neptune was the first planet discovered as a result of mathematical calculation rather than astronomical observation. Studying irregularities in the motion of Uranus, scientists posited the gravitational pull of a larger, then unknown planet. Because of Neptune's distance from the Sun, its orbit takes 165 years. That means the planet has only just completed a full circle since its discovery in 1846. The distance also makes it impossible to see with the naked eye. Neptune and Uranus are essentially twins in size. Neptune is slightly smaller in diameter, but slightly larger in mass. Neptune's interior is also similar to its twin, composed of the melted ices of water, methane, and ammonia, with a rocky core about the size of Earth. Hydrogen, helium, and methane gas make up its atmosphere. The methane absorbs red from the illuminating sunlight, giving Neptune its blue colour, similar to Uranus. The planet's winds are strong, the fastest in the solar system. Neptune has a ring system and 13 known moons. Triton is not only the largest of Neptune's moons, it is also the largest moon in the solar system, with a retrograde orbit. Now, last but certainly not least, it's time to get down onto the beach again and draw a teeny tiny little dot way out. Another 80 centimeters from Neptune. That takes us a grand total of 3.7 meters away from the Sun. Now, it's always sparked controversy. Is it a planet? Is it not? On this occasion, let's just leave that up to you to decide. Why not? We are, of course, talking about Pluto. In Greek mythology, Pluto was the god of the underworld. This god of darkness was able to make himself invisible. The planet Pluto, the outermost in our solar system, can also be described as dark and elusive. Pluto has one satellite, Charon, discovered only in 1978. Half the size of Pluto, Charon shares its orbit, and they are sometimes considered a double planet. Since its discovery in 1930, Pluto has been known as the smallest, coldest, and most distant planet from the Sun. However, we know very little about it. Since the late 1970s, most of what we know has been learned from ground-based observations, an infrared satellite mission, and the Hubble Space Telescope. We know that Pluto takes 248 years to circle the Sun. We also know that the planet revolves in a peculiar orbit, which is influenced by Neptune. Pluto plays a kind of cat and mouse game with Neptune. For a 20-year period, during its long elliptical orbit, as we said, Pluto is actually closer to the Sun than Neptune is. The last time that Pluto was in close orbit to the Sun was from 1979 to 1999. About 2/3 the width of our Moon. Pluto may be composed of a rocky core surrounded by an icy mantle. Its mass is also less than our Moon's. The planet's surface appears to have a bright layer of methane, nitrogen, and carbon monoxide. This layer thaws when Pluto moves closer to the Sun. During the thaw, a fragile atmosphere develops, with pressure of just 1/1,000,000th of that of Earth's. When Pluto moves away from the Sun, the planet's atmosphere probably freezes and then shrinks as the atmospheric pressure drops. although this is uncertain due to recent observations that seem to indicate Pluto's atmosphere is still growing. Today, some astronomers think that Pluto is among the largest of a group of objects orbiting beyond Neptune in what is called the Kuiper Belt. This belt is filled with small icy bodies of up to 600 miles in size, some of which may be comets, all formed in the early days of our solar system. Some have gone so far as to say that Pluto may not be a planet at all. You seem to have nodded off there for a wee while. My apologies. I certainly do not want to be the one to keep you awake. Just let the sounds of nature do the rest now. You've heard plenty enough from me and our solar system. Although it's fascinating, isn't it? We've got this diagram in the sand before our feet, painting a very colourful picture of our small little world, as it were, in this vast galaxy, in this even vaster universe. It really does boggle the mind. What else is out there? Are we alone? Again, you can decide that. But it's so easy to get carried away on that train of thought. So for now, to bring you back to Earth, tune back in to the crackling campfire, the gently lapping waves, and stargaze to your heart's content on this beautiful night. As interesting and fascinating as it is to take our mind out of this world and into outer space beyond our own world, sometimes it's wonderful merely to observe what we can from here on our little planet. With the moon above, the Milky Way painting itself across our sky, and the nearer stars twinkling away and glistening. We are truly blessed to have this. Sleep well.